This is the third video in the Test 3 review, and it covers material on solving trig equations. In this problem, we're told that the quantity tangent of x minus root 3 times 2 sine of x minus 1 is equal to 0, and we want to find all solutions on the interval 0 to 2 pi. So the first thing we know is that if this product is equal to 0, then either tangent x minus root 3 equals 0, or 2 sine of x minus 1 equals 0. So to find all solutions on 0 to 2 pi, we can just solve for x in both of these equations and look at the solutions on 0 to 2 pi. So on this side, we just add root 3 to both sides, so tangent of x equals root 3. And over here, we said we would add 1, so 2 sine of x equals 1, and then divide by 2. So sine of x equals 1/2. So on the interval of 0 to 2 pi, tangent of x would equal root 3 at x equals pi over 3 and x equals 4 pi over 3. And then for sine of x equals 1/2 on the interval of 0 to 2 pi, we would have x equals pi over 6 and x equals 5 pi over 6. So then our final solution for all possible values of x on 0 to 2 pi that satisfy that equation would be pi over 3, 4 pi over 3, pi over 6, and 5 pi over 6. In this problem, we're asked to solve 2 secant theta tangent theta equals 4 tangent theta on the interval 0 degrees to 360 degrees. So the first thing we're going to want to do is get this equation equal to 0, and then we can solve for theta. So we're going to subtract 4 tangent of theta from both sides. So we'll have 4 secant squared theta tangent theta minus 4 tangent theta equals 0. So when you're working with problems like this, you can generally treat it the same way you solve all equations. It can get a little scary looking because you have all these trig functions involved, but the rules are pretty much the same. So what we're going to do to take our next step to solve this is we're going to factor the equation so we can pull out a tangent or 2 tangents. So our equation is going to become 2 tangent of theta equals times the quantity secant squared theta minus 2 equals 0. So this way we have 2 different pieces that are isolating the 2 involved trig equations. So we could just do kind of like we did in the first part. We know that either 2 tangent of theta equals 0 or secant squared theta minus 2 equals 0, and we can just solve for theta. So if 2 tangent of theta equals 0, then we know that just plain tangent of theta must be equal to 0, and that's going to happen at theta equals 0 degrees and at 180 degrees. And then, so we can solve here, so secant squared theta minus negative 2 equals 0, so secant squared theta equals 2, and then secant theta equals positive or negative root 2. So there's a fair number of solutions for that. So secant of theta is going to equal positive or negative root 2 at 45 degrees, 315 degrees, 135 degrees, and 225 degrees. So you can do this by either checking on a graph, or if you have just a good concept of what your trig values are, then you should be able to solve this. So our final answer would be all 6 values: 0, 180, 45, 315, 135, and 225. So that would be our solution for theta on the interval 0 to 360 degrees. In this problem, we're asked to solve 9 sine squared theta minus 6 sine theta equals 2. So first, we're just going to move everything over to one side. So we'll have 9 sine squared theta minus 6 sine theta minus 2 equals 0. Now consider for a second that this is sort of in the form of a quadratic formula. So pretend that our sine of theta, we're just going to substitute that with u. So then this would just be 9u squared minus 6u minus 2. And we could just use the quadratic formula to find our answer. So we would know then that u equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where our a is 9, our b is negative 6, and our c is negative 2. So if we were just to plug those values in, we would use a calculator and we would find that u, which is equal to sine of theta, equals approximately 0.91 and 0 or negative 0.24. So we could just plug those values into our calculator. So we would do sine inverse of 0.91 and sine inverse of negative 0.24 to solve for theta, and we would get theta equals 65.5 degrees and 114.5 degrees. So remember, our calculator isn't going to give us everything. The results are just going to come out on a certain interval. So we would want to verify this with a graph. So if we were to graph it, we would also find that theta could also be 346.1 degrees or 193.9 degrees. So remember, you're always going to want to verify with a graph. In this problem, we want to solve sine of 2x equals root 3 sine x on the interval 0 to 2 pi. So first, as usual, we're going to put these all on one side. So we'd have sine of 2x minus root 3 sine x equals 0. Now for this, we're going to want to look for a trig identity that could help us solve the problem. So in this case, we can use our double angle formula. So we know that sine of 2x equals 2 sine x cosine x. Right? There's relatively little that we could do with this as is, which is why our next step is to look for identities that could simplify the problem. So let's go ahead and plug this in. So 2 sine x cosine x minus root 3 sine of x equals 0. So next we can factor. We can pull out a sine x. So we would have sine x times 2 cosine x minus root 3 equals 0. And from here it's relatively simple. We know that either sine x equals 0 or 2 cosine x minus root 3 equals 0. So sine of x equals 0 where x equals 0 or pi. And here we're going to solve, so we would subtract root 3, 2 cosine x equals root 3, divide by 2 cosine of x equals root 3 over 2. And we know that that happens where x equals pi over 6 or 11 pi over 6 if we're looking at the interval 0 to 2 pi. So our solutions would be 0, pi, pi over 6, and 11 pi over 6. In this problem, we want to solve cosine of 2x minus cosine x equals 0 over the interval 0 to 2 pi. So at first glance, there's not a whole lot that we can do to deal with this directly as it is, so we're going to consider some of our trig identities. So we know that cosine of 2x can also be rewritten as 2 cosine squared x minus 1. So let's go ahead and plug that into the equation we were given. So our new formula that we're working with is 2 cosine squared x minus 1 minus cosine of x equals 0. So we may recognize this as a little more workable if we write it as 2 cosine x minus cosine x minus 1 equals 0. So now we can see that it's a quadratic. So we could either use the quadratic formula or factoring to solve for cosine of x. So this would be pretty easy to factor. And remember, when we're working with stuff like this and we see that it's a quadratic, it looks weird at first because you have your trig functions in there. But just, you can rewrite it if you want as cosine of x equals u and then factor that way. You just have to make sure that you plug this back in at the end. So let's just say we have 2u squared minus u minus 1 equals 0. So if we were to factor that, it would become u minus 1 times 2u plus 1 equals 0. So looking at it that way, it seems a little easier to factor. We just have to plug our cosine of x back in. So we have cosine x minus 1 times 2 cosine of x plus 1 equals 0. And so then, similar to all our problems previously, we just solve for each part if it were equal to x. So cosine minus 1 equals 0, or we solve for each part if it were equal to 0. So 2 cosine x plus 1 equals 0. So we're looking at either cosine x equals 1 or cosine of x equals negative 1/2. So in that case, our solution set on 0 to 2 pi would be 2 pi over 3, 4 pi over 3, and 0. So just a summary of what we've covered and some of the material that'll be on the test. When you're working with solving trig equations, some of them can, for the most part, they can just be treated like regular equations. You just have to use some of your different tricks. So you're going to want to set everything equal to 0 and then solve for x. So sometimes that just involves a little bit of regular algebra. Sometimes you need to factor. Sometimes you need to consider using the quadratic equation. There's just a variety of different algebraic techniques that you can use to go ahead and solve. So that's if you're just solving it algebraically. And sometimes when you're solving it that way, it may be a little bit easier to substitute u as your cosine x or your sine x or whatever, just so it looks a little bit more manageable. But you have to remember to put this back in at the end so that you can solve for your answer. If you're given a problem and you look at it and it doesn't seem like there's anything you can do to solve it algebraically, the next thing that you're going to want to do is look at your trig identities. So using your trig identities, you should be able to substitute something in and then simplify it down to solve for x. So you're going to want to find a trig identity that might allow you to factor or something that may allow you to cancel something. There's just a variety of different things you could use. Now, you want to remember too that that includes using your half angle and your double angle identities. So all of those can be useful in solving. So just in general, don't let the trig equation scare you. You can usually solve it using some just basic skills that you've learned in algebra, or you just need to use some trig identities. Remember that you're going to want to verify, however, using a graph because there could be some additional values on your interval that your calculator's not going to give you. So if you're using your calculator to find some of these values, if you're using, your inverse function on the calculator, you're going to want to graph it. If you know your trig values and you're working with exact values, then you shouldn't need to verify it and you should be okay. So this is the final video for your test 3 review, and as always, if there's more problems that you would like to work on, you can always get on my math lab and look at the test 3 practice or review material.